Good morning, children. In the previous class, we discussed about the condensation reactions with the ammonia derivatives like with the Tumkur, DNP, and along with we have discussed about the semi-composite and some other ammonia derivatives we have discussed in the previous class. And also in the reduction reactions, that is a reduction to alcohols, we have discussed in the previous class. In this class, we are going to be discussing about the reduction to, that is hydrocarbons. That is reduction to hydrocarbons. In that, the first in this reduction to hydrocarbons, we will discuss two new reactions. These are very important for the examination purpose. So many times asked in the examination, both that is Wolff-Kishner reduction and Clemenson's reduction. The first we will discuss about the Clemenson's reduction. That is the reduction. Here the aldehydes and ketones. Aldehydes and ketones reacts with the zinc amalgam in the presence of concentrated HCl. It reacts with the zinc amalgam in the presence of concentrated HCl. It's going to be gets reduced into respective hydrocarbons. This reaction we call as a Clemenson's reduction. This reaction we call as a Clemenson's reduction. Here the general equation we can be written as, that is C11O. This undergoes reduction when it is treated with the zinc amalgam in the presence of concentrated HCl. It is going to be formed respective hydrocarbons. That is, the respective hydrocarbon is going to be formed. Means the carbonyl carbon, that is the carbonyl group gets reduced into CH2 group. The carbonyl group gets reduced into CH2 group. We will take the example for the aldehydes and the ketones in this. We will take the example. Suppose if you are going to be taken the that is acetaldehyde. That is acetaldehyde we can be written as CH3 C double bond OH. This is about the acetaldehyde. This is going to be treated with the zinc amalgam in the presence of concentrated HCl. It gets reduced into ethene. That is it gets reduced into ethene. That is CH3 CH3. It is going to be reduced into ethene. That about the ethane. It gets reduced into ethane. This is about the acetaldehyde. Acetaldehyde ನಾವು ಏನಾದರೂ zinc amalgam ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದಾಗ in the presence of concentrated HCl it gets reduced into ethane respective for hydrocarbon. If you are going to be taken back some ketone, we will take an example, that is acetone. That is CH3 C double bond O, then CH3. This we can be written like this also. That is CH3 C double bond O CH3. This is going to be treated with the zinc amalgam in the presence of concentrated HCl. It's going to be gets reduced into propane. That is CH3 CH2 CH3. That we call it as a propane. Means now either aldehydes or ketones. Either aldehyde or ketones is reacts with the zinc amalgam in the presence of concentrated HCl. Then it gets reduced into respective hydrocarbons. This reaction we called as a Clemenson's reduction. In this, the carbonyl group is going to be gets reduced into the, that is CH2 group. Then in this only we will discuss about the another reaction that will be called as the Wolff-Kishner reaction. It will be called as a Wolff-Kishner reduction. The name of that reaction is Wolff Wolff-Kishner reduction. In this Wolff-Kishner reduction, either aldehydes or ketones, aldehydes or ketones, it's going to be reacts with the hydrogen, that is NH2. It's going to be form a respective hydrazone. This again treated with the KOH in ethylene glycol. It is going to be reduced into respective hydrocarbon. It's going to be reduced into respective hydrocarbons. In this ethylene glycol is going to be heating, means it's going to be heating. In this first what aldehyde or ketone. General representation of either aldehyde or ketone is going to be represented like this. This is going to be treated with the hydrogen, means that is NH2. This is called as a hydrogen. When it reacts with the hydrogen, the aldehyde or ketone reacts with the hydrogen. That time removal of water is going to be taken. That I am going to be mentioned here. That is H2O. It's going to be removal of the H2O molecule. Then it's going to be formed with respect to hydrazone. That is NH2 respective hydrazone is going to be formed. This on treated with the followed by on heating with the KOH. That is KOH and ethylene glycol. That is on heating is going to be form a respective hydrocarbon. That is going to be, we are going to be get that respective hydrocarbons we are going to be get. There is about that is this reaction we called as a Wolff-Kishner reaction. This reaction we called as a Wolff-Kishner reaction. In this, what happens? Either aldehyde or ketone is going to be treated with the hydrogen. Removal of that is the H2O molecule is going to be form a respective hydrogen. These are heating with the that is KOH, that is the potassium hydroxide. In the ethylene glycol is going to be get the respective hydrocarbon. We will take the example for this. Example the first aldehyde term. Aldehyde that is CH3 C double bond OH. Then this is going to be treated with the hydrogen. That is removal of water molecule, that is H2O. Then it's going to be formed a CH3 acetaldehyde hydrazone. This acetaldehyde hydrazone is going to be formed. This on again treating with the KOH, that is potassium hydroxide, and ethylene glycol. Then on heating it's going to be formed, that is CH3 that is going to be formed, that is ethane. The name of this compound is acetaldehyde. This on treating with the hydrogen, it's going to be formed, that is acetaldehyde, the hydrazone. Then this on treated with the KOH is going to be, and the product they are going to get, that is ethane. Then like this one we will take the acetone. Acetone will take the example CH3 C double bond O CH3. Then the name of this compound is acetone. This is going to be treated with the hydrogen. This is going to be treated with the hydrogen. That is removal of H2O. Then it's going to be formed, that is CH3 acetone hydrazone. We are going to get that acetone hydrazone. We are going to get that acetone hydrazone. Then this again is treated with the, that is KOH called as a Wolff-Fishner reaction. This is also very important for the examination purpose. So many times asked with these two reactions in the examination. That is reduction to hydrocarbons. Andre aldehydes na ketones na yav tara reduce ಮಾಡಬಹುದು ಯಾವುದಕ್ಕೆ hydrocarbons ಇಂದ. These two main reactions we are going to be used. That is Clemenson's reduction and the Wolff-Fishner reduction. This is about the reduction to the hydrocarbons. The next we are going to be discussing about that is the oxidation of aldehydes and the ketones. Next now we will discuss about the oxidation of aldehydes and the ketones. That is about the we will discuss now oxidation of aldehydes and ketones. Oxidation of aldehydes and ketones. In this, now we will discuss about the oxidation of first aldehydes. Aldehydes easily undergo the oxidation. It's going to be formed by respective carboxylic acids which contains the same number of carbon atoms. That is, aldehydes easily that is oxidized into respective carboxylic acids which contains the same number of carboxylic acid. Generally the equation we are going to be represent like this. That is the aldehyde. This undergoes the oxidation. In the presence of undergoes oxidation. It's going to be use the respective carboxylic acid which contains the same number of carbon atoms. This is the aldehyde. This undergoes oxidation. It is going to be used the carboxylic acid. Here, but the aldehydes easily undergoes the oxidation. Easily oxidized into carboxylic acids. But the ketones gets oxidized in the vigorous conditions. And the elevated temperature and the presence of strong oxidizing agent. Andre aldehydes easily oxidize agutte but ketones easily oxidize agalla. It needs some particular favorable conditions. That means it needs the strong oxidizing agent and the vigorous conditions. It undergoes the oxidation in the vigorous conditions and the another elevated temperature. In the presence of the elevated temperature, the ketones gets oxidized into carboxylic acid by the cleavage of carbon-carbon bond. It forms a mixture of carboxylic acids. In a mixture of carboxylic acids, then it contains the less number of carbon atoms compared to the reactant. We will take the example. That is general equation. We will write the general equation. Suppose there is a general equation. Generally, I am going to be representing the ketone. Then, if you are going to be taken the carbon, that is this is a carbon 1, 2, 3. The carbon 1, 2, 3. This undergoes the oxidation. In the presence of strong oxidizing agent. Now elevated temperature under the vigorous conditions. The cleavage of the carbon bond is going to be takes place. It is going to be formed a mixture of carboxylic acids which contains the less number of carbon atoms. Mixture of carboxylic acids form COOH, then plus R dash CH2 COOH here. The mixture of carboxylic acids are formed. These are formed by cleavage of the C1 C2 bond between the carbon and 2. That is either one more possibility is there. Either the cleavage of this bond is going to be take place carbon 1 and 2, either cleavage of the carbon 2 and 3. We are going to be get that is RCH2COOH plus R dash COOH. Make sure these products are obtained by cleavage of that is C to C3 bond. Means the ketones ಏನಾಗುತ್ತೆ respective carboxylic acids ಆಗಿ ಆಕ್ಸಿಡೈಸ್ ಆಗುತ್ತೆ. ಯಾವಾಗ ಆಕ್ಸಿಡೈಸ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ vigorous conditions, it needs the vigorous conditions, elevated temperature and the strong oxidizing agent. ಅಲ್ಲಿ ಕೂಡ cleavage ಆಗುತ್ತೆ. Mixture of carboxylic acids is going to be used which contains less number of carbon atoms. This about the oxidation of aldehydes and ketones. The aldehydes undergoes the oxidation. It gets reduced the strong oxidizing agents like that is K2Cr2O7, KMnO4. Then mild oxidizing agents like Tollens reagent, then Felix solution and Benedict Skiff's reagent like this. Therefore, it acts as a good reducing agent. Therefore, it acts as a good reducing agent. Now we will discuss about how it's going to be reduces the Tollens reagent. We discuss now how it's going to reduce the Tollens reagent and the Felix solution. Now we will discuss with Tollens reagent. First we will discuss with with Tollens reagent. This Tollens reagent is nothing but ammonical silver nitrate solution that we call as a ammonical silver nitrate solution. Here it's going to be with the Tollens reagent. It's going to be that is aldehydes and ketones. This the aldehydes is going to be reacts with the Tollens reagent. Then it's going to be forming it gets oxidized into carboxylic acids and is going to be formed a black PPT or silver mirror is going to be formed. Here that is aldehydes, that is RCHO is going to be treated warming with the that is Tollens reagent. That is we can be written as AgNH3 twice, then plus this we call it as a Tollens reagent. Then it's treated with the Tollens reagent. That is it's going to be formed that is OH minus that is 2. Then it's going to be formed a respective carboxylic acid. It gets oxidized into respective carboxylic acids. Then it's going to be formed that is H2O Ag plus NH3. Then this is going to be 2H2H2. This about the black color PPT is going to be formed. That is aldehydes is going to be treated with the Tollens reagent. It's going to be formed by respective carboxylic acids. That is it. Going to be formed by black color PPT or silver mirror. This about the reaction we are going to be written. Next we are going to be discussing about the with Felix solution. Here Felix solution is nothing but that is alkaline cuprous that is a cupric tartarate solution. Alkaline cupric tartarate solution is called as a, that is called as a cupric tartarate solution is called as a Fennings solution. That is alkaline cupric tartarate solution is called as a, that is Fennings solution. Aldehydes is going to be heated with the aldehydes is going to be heated with the, that is a Fennings solution. It's going to be formed, that is the red color PPT, PPT of cuprous oxide. Then it's going to be the aldehydes, that is the equation we can be written as RCHO. Is going to be treated with the Fennings solution, that is CO2 plus. Is going to be treated with the CO2 plus, and the presence of these, that is base, is going to be base. It's going to be formed the base. Then it's going to be formed, that is it's going to be formed, that is respective carboxylic acid, that is RCOO dash CO2O plus. It's going to be formed, that is H2O, that is 3H2O. 3H2O. That is going to be P to balance. Thus about the, that is Fennings solution. Is about the Fennings solution. Means aldehydes gets oxidized into respective carboxylic acid with the Fennings solution. It's going to form a red PPT. It's going to form a red PPT of the cuprous oxide. Next class we will discuss about the another chemical properties of this aldehydes and the ketones.